Excellent. Well, good afternoon. Today I'm going to be discussing some of the challenges that we face trying to operate pit tag arrays under some extreme flow conditions that we experienced in the Potlatch River. I wanted to point out here when I got started that pit arrays are an important tool in our wild steelhead monitoring program in the Potlatch. And we utilize arrays to try to estimate adult escapement as well as monitor juvenile survival and life history patterns. So the Potlatch River experiences highly variable and at times extreme flow conditions that really make it challenging to operate and maintain pit tag arrays. This hydrograph here does a really good job of illustrating the annual flow characteristics in the Potlatch. High flows in the spring, followed by low base flows here in the summer. Now, looking at this data from 2017, you can see that the difference in the flows between the spring period and summer can be rather dramatic. And for my talk today, I'm going to be focusing on the spring flow. This is the time period that we really struggle with in trying to hold and maintain arrays in our streams. Now, it's not flows alone that are a challenge to us, but the substrate conditions at our array site is also problematic. So many of our site locations are located lower in the stream, and the streams in the lower Potlatch are relatively high gradient, have a lot of rocky substrate, and this substrate mobilizes and deposits downstream during high flow events. And so this picture does a really good job of kind of illustrating what we see. These large rock bars can extend for hundreds of yards. They can form after one or two flow events and be gone the following year. So imagine trying to set and hold anchors in this type of substrate that mobilizes so quickly. That is a very big challenge that we face. Okay, we operate a handful of arrays throughout the Potlatch. Just going to talk about these two here in the lower system. At our main stem, an array on a main stem site, as well as the site here on Big Bear Creek, which is major tributaries of the lower Potlatch. So starting with the main stem site, our first iteration of this site, we attempted to use the flat panel design. So just a typical setup, dual span. We had three 20-foot panels in each span. These were anchored with a threaded rod. You can kind of actually see them here in the installation picture. Driven down into the substrate attached to a duckbill anchor. Now we put these flat panels in the fall of 2008. We got about 2 seasons out of them, and without any major disturbance or outages, and we collected some really valuable data. Unfortunately, in the spring of 2011, during a high flow event, we had a rather large boulder come downstream, and it decided to land basically right on our antenna. This boulder ended up taking out 4 of our 6 antennas at that time. Now we went back in the fall of 2011, reinstalled 4 more panels in a single span, only to see those 4 panels wiped out the following spring during another high runoff event. So at this point we took a breath, decided, all right, we need to try a different approach here at this site. So in 2013, we collaborated with Biomark to design and install these floating antenna panels here. And at this site, we installed a single span of 8 of these 10-foot antennas. Now our intent, and I should just point out that these antennas were attached with nylon strapping here to a steel cable that ran across the stream. Now our intent was to establish this single span of floating panels and then go back in and add an additional upstream span of in-stream flat panels again in order to maximize detections of both adult and juvenile fish. So we spent a good portion of 2013 testing and troubleshooting this system here. Specifically more of the rigging techniques that we were using in order to keep these panels from either porpoising in the water or they tended to want to actually lift up off the water during high wind events. Now, unfortunately, the following spring, before we could even get these panels installed, we experienced another high flow event where a tree came down, and it pretty much permanently damaged both our anchor and our cabling system. So at this point, we halted operations here at our main stem site, and we actually felt that these floating panels might be better utilized elsewhere within our watershed. And so I'm going to switch gears now and talk about our Big Bear Creek array site, where we ended up using these floating panels. So in the first 7 years of operating the Big Bear Creek array site, we utilized the old school standard PVC antennas here. These were anchored, you can kind of see the nylon straps here around, anchored into the substrate with the duckbill anchor. We had multiple configurations over the years, but our anchoring was fairly consistent across these years. Now, over these 7 years, we were plagued by consistent and frequent loss and damage of these antennas. Either the antennas themselves were damaged, or what was happening more often was we were losing entire antennas during these high flow events. And so when the substrate would mobilize, it would take both the antennas as well as the anchors with them downstream. So at this point, we were constantly going back into the stream, putting these antennas back in after flow events, sometimes multiple times during the spring. This graph here just kind of shows our operational status for the Big Bear Creek array for our first 7 years of the site. I want to point out this is just for the spring operation, spring period only. We don't operate this array during the summer because the site actually goes dry during the summer. So you can see in 2008, we struggled mightily to hold and maintain antennas in the array and in the stream. It seemed like we would lose antennas after every single little flow event. But we refined our anchoring technique, and we were getting a little bit better here in 2009 and 2010. And we're actually feeling pretty good about ourselves in 2010 and about our ability to hold an antenna in the stream. Unfortunately, 2010 was an uncharacteristically low spring year. So reality really slapped us in the face again in 2011 and 2012, which were both high flow years. And once again, we struggled to maintain our rates in the stream. So overall, on average, we're able to keep the site operational to some extent for about 2/3 of the time. And unfortunately, those downtimes tended to coincide with sort of the heart of the migration period. So we were really thinking we needed a different approach here at this site. So in 2015, we ended up utilizing those floating panel antennas that failed on the main stem here on Big Bear Creek. So we just set up a dual span with 4 antennas in each. Once again, they were attached to a cable that went across the stream. One interesting thing is the levee here, and we couldn't really anchor much into the stream. So our cable was actually attached to a steel box filled with sandbags. And it actually had a crank system on it, which allowed us to move the antennas back and forth across the stream. So we ran these antennas here for 2 years, 2015 and 2016, without any major outages. We were pretty happy with it. Now, we did fish these conservatively. So we would pull these panels at high flow events, and then we'd redeploy them following when the flow started to subside. So starting in 2016, we made some modifications here, and what we tried to do is install this sort of hybrid design or concept that we were wanting to do on the main stem site in order to sort of maximize the quality of the data that we're collecting. So we kept our floating panels in place where they were, and then upstream about 1 kilometer, we put in an in-stream span here using the stronger HDPE antennas, and these were mounted with the threaded rod here through the struts of the antennas themselves. And our thought was that, you know, this combination design would do better for maximizing detections of juveniles and adults. The floaters did a really good job with juvenile detection. Those juveniles higher up in the water column, those antennas did well with the juveniles. Whereas the in-stream antenna did better with the adults that were lower down, working their way up the bottom. Now, reality set again in 2017 when during yet another historic runoff event, we lost both our floating antennas as well as our in-stream antennas. Now, the good news is we were able to recover all of our floating panels, some of which made it a couple miles downstream. And actually, one encouraging aspect of the failure of the in-stream site was we actually held our anchors. And what ended up happening is we actually snapped the struts off the antennas themselves. And so what we think happened is we had excessive scouring at the site, which allowed the antennas to vibrate, and it actually snapped the plastic welds. So we were actually encouraged by the fact that we held our anchors for once. And so, you know, silly or not, we decided to go ahead and reinstall this again here this spring. We addressed the scouring issue, and we're kind of utilizing this hybrid design moving forward, and hopefully we'll be able to hold these in the system a little bit longer. So just to wrap things up here, you know, our sites on the lower potlatch, especially these floating panels, require constant maintenance and oversight. You're constantly addressing and messing with the rigging technique to get the panels to sit on the water. In contrast, we have other sites in the upper potlatch that, as mentioned before, relatively little maintenance compared to some of these lower sites. We're continuing to tinker with our design and evolve it and change it over time in order to maximize the data that we're collecting. We really feel that this hybrid design that we're working with right now kind of gives us the best of both worlds in terms of juvenile and adult detection. We tend to think of the RRAs as more of a continual investment than a one-time cost. And so we try to be really proactive in both our funding and staffing to keep these sites operational. And lastly, I think we're really pushing the limits of some of the current systems on the market, both in terms of the availability of anchoring systems and the materials that these antennas are made of themselves. So hopefully over time we'll continue to see innovations in these issues and aspects that will allow operating arrays in such a highly variable and extreme system more feasible moving forward. Thank you.